Good morning, students. We have been discussing the various methods to solve the differential equations. We have discussed variable separable method, homogeneous differential equation method, non-homogeneous differential equation method, and today we will be learning linear differential equations. So, linear differential equations. A differential equation of the form d power n y by dx power n plus p1 d power n minus 1 y by dx power n minus 1 plus p2 into d power n minus 2 y by dx power n minus 2 plus etc. plus pn, where p1, p2, p3, etc. pn are they are either constants or functions of x only is called linear differential equation of nth degree Here, dependent variable that is, what is the dependent variable here? Y, and its differential coefficients also called derivatives occur in the first degree and are not multiplied together. Here, this y dependent variable and the differential quotients dy by dx or d square by dx square are not multiplied together, then this is said to be a linear differential equation. So, if we discuss the examples, dy by dx plus y is equals to e power minus x. Here, this is a linear differential equation of order. What is the order? First order, dy by dx, differentiating y with respect to x for one time. So, therefore, the order is equals to how much? 1. And if you take some more examples, dy by dx plus y is equals to e power minus x. So, here, y dependent variable and its derivative dy by dx and dependent variable and its derivative are of the first degree. So both are first degree. What is the first degree? So this is the first order. This is the first order derivative and its power is 1 and its power is also 1. Therefore, this is the linear differential equation of order 1. And here, x d square by dx square plus 3 dy by dx minus 7 equals to 0. So, y is the dependent variable, dy by dx and d square by dx square are its differential coefficients. In other words, derivatives. So, and y and dy by dx or d square by dx square are not multiplied together. So, therefore, this is also a linear differential equation. But so this is the first order derivative and this is the second order derivative. This is also the linear differential equation, but here order here is equals to 2. Let us see this. So here y is the dependent variable, dy by dx is the its derivative. Now here this is the first order. This is the first order derivative, but its degree. Its degree is, what is degree? Degree is defined to be the power of the highest order derivative. So here dy by dx first order derivative, and first order derivative's power is the degree here. So here degree is 2, but the degree should be 1 because y dependent variable and its derivative both are in the first degree and they should not multiply with each other. But here y and dy by dx are multiplied with each other. Therefore, this is not a linear differential equation. Earlier, these two are linear differential equations only. Linear differential equations. Let us see this. Y divided by dx plus 2y equals to x. Clearly, this y dependent variable and its derivative are multiplied with each other. Therefore, this is also not a linear differential equations. So, these are the few examples for a linear differential equation. In this module, we will discuss the first order and first degree differential equation only. So, the most general form of a linear differential equation is of the form dy by dx plus py equals to q, where p comma q are either constants or functions of x only, and p comma q are continuous functions. So, continuous functions of x only. So, this is the first order, first degree linear differential equation. So, now let us multiply with e power integral p dx on both sides. Then e power integral p dx into dy by dx plus py is equals to e power integral p dx into q. This is equals to e power integral p dx into dy by dx plus py into e power integral p dx is equals to e power integral p dx into q. I just multiplied this with each term throughout the equation also. Now this can be written as d by dx of y into e power integral p dx is equals to e power integral p dx into q. So this can be written as d by dx of y into e power integral p dx is equals to e power integral p dx into q. So the reason why I have written this to be this will be explained here. See this, d by dx of y into e power integral p dx is equals to, so let us suppose this is u and this is v. D by dx of u into v is u v dash plus v u dash. So this is y into d by dx of e power integral p dx plus e power integral p dx into d by dx of y. So uv is u v dash plus v u dash. This is equals to 5 into, so d by dx of this, let us suppose this whole to be x. What is d by dx of e power x? E power x only. So e power integral p dx only into, since we have treated this to be x, later we need to differentiate it, which we have discussed last year, into d by dx of integral p dx. Since e power this is x, since I have treated it to be x, we need to differentiate it later, plus e power integral p dx into d by dx of y is dy by dx. This is equals to 5 into e power integral p dx into, this is p into d by dx of integral 1 dx. D by, p since it's a constant, I have separate from the process of integration, d by dx of integral 1 dx plus e power integral p dx into dy by dx. So this is equals to 5 e power integral p dx into integral 1 dx. This integral 1 dx is x. D by dx of x 1. So p into 1 p plus e power integral p dx into dy by dx. Now you may compare this with this. See, in e power integral p dx into dy by dx. So this is equals to this, p into y e power integral p dx. So this is the result of y e power integral p dx. Therefore this I have written it to be this. Hope you understand this. Again I am telling you, e power integral p dx, I have just multiplied this with these two terms and here also. So the whole thing I have written it to be y into e power integral p dx. The reason I have explained here, d by dx of y into e power integral p dx is this. Therefore y into integral e power p dx into p, that is this, plus e power integral p dx into dy by dx is this. So therefore this can be transformed with this or not? Now integrating on both sides. Integrating on both sides, we get integral of d by dx of y into e power integral p dx. When we are applying integral, with integral dx also will be existed, is equals to integral of e power integral p dx into q into dx. So Since integration and differentiation are the opposite processes, therefore we get y into e power integral p dx is equals to integral q into e power integral p dx dx. Therefore, the general solution of the differential equation of first order and first degree, which is dy by dx plus py equals to q is. So the general solution of this is, how much we get? Y into e power integral p dx is equals to integral q into e power integral p dx into dx. So this is what we get. So this is equals to, here e power integral p dx is said to be the integral factor. So therefore, it can be rewritten as y integral factor is equals to integral q into integral factor into dx. For the differential equation dy by dx plus py equals to q, where p comma q are in terms of x. Here x is independent variable. Therefore, p comma q are either constants or the functions of x, and those functions are continuous functions. Or the differential equation can also be in the form dx by dy plus px equals to q, where p comma q are constants or functions of, can you guess, functions of independent variable. Therefore, p comma q are either constants or functions of y, or functions of y. Now, its general solution is, since this is dy by dx plus py equals to q, I have started with y here. Integral factor is equals to q into integral factor into dx. So here I should start with the x here. X into integral factor is equals to q into integral factor into dy. So here integral factor, here can you guess, integral factor is equals to e power integral p dy. Here integral p dx. So let us write the differential equation and its general solution. If the differential equation is of the form dy by dx plus py equals to q, then its general solution is of the form y into integral factor is equals to integral q into integral factor into dx, where integral factor is equals to e power integral p dx. So, and p comma q are the continuous functions of x. P comma q are continuous functions of x only, or it could be of the form dx by dy plus px equals to q. So here y, this is y. Here x, this is x. So here the general solution is starting with x. X into integral factor is equals to integral q into integral factor into dy. So p comma q or in terms of p comma q or in terms of the independent variable y or in terms of y or continuous functions of y or constants also. So this is what is the integral factor here, where integral factor is equals to e power integral p. If you got a doubt, e power integral p, dx is to be written or dy is to be written. Here p comma q or in terms of y, therefore p is associated with the dy. So this is what we have discussed so far. So based on this, let us work out the exercise 8E. So this is the first problem from the exercise 8B. Find the integral factor of the following differential equations by transforming them into a linear form. X dy by dx. So students are requested to correct this in the textbook. It is dx by dy is given. That is why after explaining all everything, I got realized and I just corrected it, and again I am shooting this solution. Okay, so this is dx by dy is mentioned in the textbook. It is not dx by dy, instead it is dy by dx. Okay, so first of all, what is the linear differential equation? It will be one of these two forms, dy by dx plus py equals to q or dx by dy plus px equals to q. It could be one of these two forms. First of all, what is a linear differential equation? A differential equation is said to be linear if the dependent variable y and its derivative dy by dx both should be of first degree. So actually both are having the power 1. This is first order, and first order's power is 1, that is degree is 1. So both dependent variable y and its derivative should be of degree 1 and they should not multiply with each other. Let us divide this solution, dividing by x throughout the equation. Then this is dy by dx minus y by x is equals to 2x square secant square 2x by, this is x gets cancelled. This can further be written as dy by dx plus minus 1 by x into y is equals to 2x secant square 2x. So this is clearly of the form dy by dx plus py equals to q, first one. So where it is in the form dy by dx plus py equals to q, where p is equals to e power integral p is equals to minus 1 by x. So here what is the integral factor here? E power integral p. Do not confuse as what to be written, dx or dy. So here p comma q are in terms of the independent variable, therefore p is associated with dx. So here integral factor is e power integral p dx, e power integral minus 1 by x dx. So e power integral 1 by x dx is log x. This is equals to e power minus log x can be written as log x power minus 1. M log a is log a to the power of m. So e power log vanished. We are getting x power minus 1, which is 1 by x. So 1 by x is the integral factor of this linear differential equation. So let us see here. Y dx by dy minus x is equals to 2y cube. So first of all, this is dx by dy plus px equals to q. So dx by dy's quotient y should not be there. So to make this is free from y, we have to divide with y throughout the entire equation. So let us do this. So dividing by y on both sides, this is equals to dx by dy minus x by y equals to 2y cube by y. So y square times. So this is equals to dx by dy plus minus 1 by y into x. So see that actually all the time, if this is y and this is y, should be matched with each other. Here x and this is x is equals to 2y square. So this is clearly of the form dx by dy plus px is equals to q, where p is equals to how much? Minus 1 by y. Therefore, what is the integral factor? E power integral p. So since p and q are in terms of y being the independent variable, p comma q are constants or functions of y only, okay, which are continuous functions. Therefore here integral factor is equals to e power integral p, since this p is in terms of y, dy. So this is e power p is minus integral p is minus 1 by y. Take minus outside, 1 by y dy. So this is equals to e power minus integral 1 by y dy is log y. So e power log y inverse. So y inverse, which is equals to 1 by y. Therefore 1 by x is the integral factor for this and 1 by y is the integral factor for the second question. Hope you understand. Let us solve the second Roman of this exercise. Solve the following differential equations. That is, we need to find the general solution at the end. So dy by dx plus y tan x equals to cos cube x. This is equals to, first let us try to write in a proper form of a linear differential equation. Dy by dx plus tan x into y. See, this y and this y we got equal is equals to cos cube x. I did not write anything except and write it in a proper form. Now this is in the form. This is in the form dy by dx plus py is equals to q, where p is equals to tan x, q is equals to cos cube x. So integral factor is equals to e power integral p. Since this p is in terms of x, dx. E power integral p is tan x dx. E power integral tan x is log mod secant x. Log mod secant x. So e power log, that means this is secant x. Since e power log f of x is equals to f of x, which we have discussed in the lower classes. So this result we are extensively using throughout the entire chapter. So this is equals to, now what is the general solution for this? General solution is, let us start with the y. So y into integral factor is equals to q into integral factor into dx or dy. So this q is in terms of x. Integral factor is also in terms of x. Therefore it is obviously dx. Now y into integral factor is secant x is equals to q is equals to cos cube x into integral factor is secant x dx. This is equals to cos cube x. Secant x can be written as 1 by cos x dx. So this cos square x times. Integral cos square x dx we don't know, but it can be written as 1 plus cos 2x by 2 dx. This is equals to 1 by 2 integral 1 dx plus 1 by 2 integral cos 2x dx, right? So 1 by 2 integral 1 dx is x plus 1 by 2 integral cos 2x. Let us suppose this 2x be x. Integral cos x is sin x. So sin 2x 5. 2x by dy dx of 2x is 2. 2 into 2 4 plus constant of integration c. So y secant x is equals to. So you may end up with this step. Otherwise you may even take 4 as an LCM. Then 4y secant x is equals to 2x plus sin 2x plus 4c can be written as c dash is the required solution for this linear differential equation. See this question, dy by dx plus y secant x equals to tan x. This can be written as dy by dx plus secant x into y is equals to tan x. So this is clearly of the form dy by dx plus py equals to q, where p is equals to secant x, q is equals to tan x. So integral factor is equals to e power integral p, since p is in terms of x, dx. So e power secant x dx. So e power integral secant x dx is log mod secant x plus tan x. So this is equals to e power log f of x is nothing but f of x. Therefore e power log is getting cancelled, secant x plus tan x. For the sake of understanding, I am just cancelling it. Actually, it is not getting cancelled. E power log f of x is f of x. Okay. Now, general solution is, I should start with y into integral factor is equals to integral q into integral factor into dx. This is y into integral factor is secant x plus tan x is equals to q is tan x into secant x plus tan x dx. This is tan x into secant x. So secant x tan x dx plus tan x into tan x is tan square x dx. So this is equals to integral secant x tan x dx plus integral tan square x dx, we don't have a formula for this, but secant square x minus tan square x equals to 1. So secant square x minus 1 is equals to tan square x. This is secant square x minus 1 dx. Y into secant x plus tan x is equals to integral secant x tan x dx is secant x. Integral secant square x dx is tan x minus integral 1 dx is x plus constant of integration c is the required solution. So this is dy by dx plus minus tan x into y is equals to e power x into secant x. So this is clearly of the form dy by dx plus py equals to q, where p equals to minus tan x, q is equals to e power x into secant x. So integral factor is equals to e power integral p dx. E power integral p is minus tan x dx. E power minus integral tan x is log mod secant x. Log modulus of secant x. So e power log this minus log secant x. Minus can be written as minus 1 na? So log minus 1 log secant x can be written as log secant x inverse m log a to the power of m. So this is secant x power minus 1. This is 1 by secant x, which is cos x. This is the integral factor. And what is the general solution now? General solution is equals to, start with y. Y integral factor is equals to q into integral factor into dx. So y into integral factor is cos x is equals to q e power x secant x into integral factor is cos x dx. This is equals to e power x. Secant x and cos x are reciprocals to each other. Secant can be written as 1 by cos. Cos gets cancelled. So we are left with e power x dx only. So this is integral e power x dx is e power x plus constant of integration c. Y cos x is equals to is the required general solution. Now the fourth question is x dy by dx plus 2y equals to log x. So first of all, this dy by dx coefficient should be 1 because it is of the form dy by dx plus py equals to q, or dx by dy plus px is equals to q. So in both the cases, the coefficient of dy by dx or dx by dy should be 1. That is free from any coefficient. So here x is being multiplied with dy by dx. So let us divide the entire equation by x. So dividing by x on both sides. This is equals to dy by dx plus 2y by x equals to log x by x. So this is equals to dy by dx plus 2 by x into y. So this is dy by dx plus py is equals to q log x by x. This is of the form dy by dx plus py equals to q, where p is equals to 2 by x Q is equals to log x by x. So with integral factor for this linear differential equation is e power integral p dx. E power integral p is 2 by x dx. E power 2 and separating from the process of integration 1 by x dx. E power 2 integral 1 by x dx is log x. So 2 log x can be written as e power log x square. E power m log x is log x to the power of n. E power log x square. E power log gets cancelled. We are left with x square. So now general solution is start with y into integral factor is equals to q into integral factor into dx. So y into integral factor is x square is equals to q is log x by x into integral factor is x square dx. So this x and this x gets cancelled. This is x log x dx. So you might have aware x log x dx. So you might be knowing how to integrate this. This is the product of two functions. So x is the algebraic function, log x is the logarithmic function. So the first function can be assessed by the phrase isolate. Here L comes first and then A. So the first function is log x. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. F of x into integral of g of x dx minus integral of d by dx of f of x into integral g of x dx whole dx. Integration by parts when the integrand contains the product of two functions. This is equals to log x integral x dx is x square by 2 minus d by dx of log x is 1 by x. Integral x dx is x square by 2 dx. So this and this gets cancelled. X square by 2 log x minus 1 by 2. Integral x dx is x square by 2 plus constant of integration c. So this is y into x square is equals to.
This is the required general solution of the given differential.